everyone, we are Team VisionForge, a platform to design neural networks and deep learning architectures without writing a single line of code and build production-ready models for PyTorch and TensorFlow. We visually design, validate, and export clean PyTorch or TensorFlow code to get your idea from idea to deployment in minutes. All you have to do is use our powerful tools for modern AI development through our visual intuitive builder, automatic shape inference engine, intelligent validation engine, and save and share your projects across the teams. We support multiple frameworks like PyTorch and TensorFlow, give production clean code, and can develop complex architectures with custom layer support. So let's dive into the platform and see how it works. So here I have a new PyTorch project created for myself. All I do is start out with an input node that defines the input that my architecture takes. So in this input node, you can define different properties such as the input shape, and you can also define a label here. So as you can see, we also provide quick presets for the classic default shapes for different modalities. Let's say that you want an image, you can select the image preset or the text preset, audio, or tabular data. Let's go ahead with image for now. So after I add my input node, I can start defining my layers using the base layer components. So let's say I add a convolutional layer here, and I can connect my input to my convolutional layer through the connection. And as you can see, the input of the convolutional layer was automatically inferred from the output of my input layer. And then I can configure how many number of channels do I want to output from this convolutional layer. Let's say I projected into higher dimensions and input 200 output 200 output channels. After passing through a convolutional layer, let's add a max pooling layer for ourselves to normalize the inputs. And as you can see, the outputs and the inputs of this max pooling layer was also inferred automatically. Then let's flatten out these inputs using a flatten out layer. And then again, normalize everything using a simple batch normalization layer. Add those connections. And as you can see, again, the inputs and the outputs were inferred automatically. Then also add some dropout regularization in order to make sure that our architecture is generalizable. I connect these, and then in the end, let's end with a a fully connected linear layer and add a activation function on top of it. So we support ReLU and softmax as an activation functions. So after our ReLU activation, let's just connect an output node in order to end our architecture. So once we are happy with the output node, we can just like add our output node. So you can even define custom nodes for yourself, something that we don't support if you are doing some new research and you just developed a new architecture. So inside the custom layer, you can edit out your own code and create your own classes so that you can add your own custom logic into the architectures as well. All you have to do is define a forward pass for PyTorch and a different forward pass for TensorFlow based projects. You can initialize any layers and like any things that you need in the init method, and you can create this as a new layer, but we won't do that here. So let's just delete this node for now. And once you're done with your architecture, you can even validate it. So right now, as you can see, I never configured the parameters for the linear layer, so it would complain for me. Let me just validate the architecture. So as you can see, it told me that, hey, the layer requires output features. So I have to set those. This way, you can ensure that your neural architectures will never be wrong and you don't have to sit through hours of debugging. So let's say that I want 20 output features from my linear fully connected head. So I will say that, hey, I have 20 classes, so give me 20 output layers. So now, as you can see, as soon as I define the outputs for my linear layer, all of the outputs for the following blocks were also defined. If I click validate again, as you can see, it says that, hey, no issues were detected and you can go ahead with implementing your architecture. Once I'm happy with my architecture, I can export all of my code in the form of PyTorch code. So as you can see, it generates a very modular, very highly documented and high quality PyTorch code for my model based on all of the layers that I've just defined. So the 2D convolutional layer, followed by the max pooling layer, followed by the flattening layer, and the batch normalization layer. If I change my architecture in any way, so let's say let me just remove the max pooling layer from here, and let's say I remove the max pooling layer and I define the I straight up connect the convolutioner to the flatten. As you can see, the code will update to reflect that change. So as you can see, now we have a convolutional layer and we have a flatten layer. We don't have a max pooling layer anymore. It also creates a training file for you that defines the training code for your model so that you can train your models locally. It also creates an automatic data loader for you based on the input that you have defined so that you can load your data sets during training easily. And it also creates a configuration file for you that defines all of the different hyperparameters that you can use in order to train your model to the most efficient way. Now let's just create a new project for ourselves that is based on TensorFlow instead of PyTorch. So if I create a new TensorFlow project and I name it something like new project and I create the project, we say that you don't want to create your architecture yourself. We also have a chat utility that is powered by Claude in the background, so you can enable the agent mode by selecting this toggle here and say you're reading through a research paper that you're trying to re-implement. So you can just upload the research paper here and then you'll be able to create that architecture defined in the research paper automatically. So I have this file architecture.txt that defines the architecture of a simple CNN that I am asking Claude to implement. So hey, implement this architecture for me. I send this request to Claude, and as you can see, Claude gets to work in implementing this architecture. And it tells me that, hey, I need 7 nodes in order to do that. I apply all the changes. And as you can see, Claude just added all the 7 nodes required. Once I'm happy with the nodes, I can say that, hey, connect all of these nodes as required and complete the architecture for me. And once I give Claude this command, Claude gets to work and creates all of the connections that are required in order to complete this architecture automatically. And as you can see, Claude is done creating all of the architecture. And I can even test this architecture by clicking on the validate button. So as you can see, the architecture is valid. And I can export my code as a TensorFlow code this time rather than PyTorch because this is a TensorFlow project. So as you can see, all of the layers updated in order to reflect the TensorFlow code rather than the PyTorch code. And the code is still completely modular and it is completely plug and play. So you can add and remove layers later as well. It also creates the training file, the data loader, and the configuration file for you. You can download all of these files in order to train your model locally. So let me just download this zip file. So I just downloaded this zip file. Let me call it something like model and then like save it. So as you can see, I literally just created an entirely new custom architecture in seconds without having to type a single line of code. And I can rapidly prototype such architectures for myself. And that's VisionForge. I hope you enjoyed the project. Thank you.